What's up, guys? Welcome back. In this video, we're going to be tackling question 3, which is find the curvature of vector RT, which is t ln t and t ln t at the point 1, 0, 0. So I think the easiest way for me to do this problem is to remember that curvature of t, one method is kt equals the magnitude of r prime t. There. Cross product r double prime of t here, which is the second derivative, over the magnitude of the first derivative of t cubed. Doesn't look very fun, but it's relatively simple. So let's just hop into it. And first off, let's find r prime of t, which, as you know, when you're doing the derivative of a vector, you're just doing the derivative of each part. So the derivative of t would just be 1. And the derivative of ln t, if you remember, is just 1 over t, or t to the negative 1, whatever's easier. I'll actually write it as t to the negative 1 because I think it's easier when doing second derivatives. And then the derivative of t times ln of t, that one we're going to have to do the product rule. Sorry, brain fizzed out there for a second. So that would be derivative of t is 1, so that'd be derivative of t times ln of t plus, and then t times the derivative of ln t, which would just be t to the negative 1. And there we go, that's our r prime of t, which I'll just simplify it down a little bit, is 1 t to the negative 1, and then that would be ln of t plus t times 1 over t, which is just 1. So that's ln of t plus 1. Now we just find our double prime of t. Forgive me if I keep forgetting to put the line over to put these in vector notation. It's a bad habit of mine, but pretty sure it's understandable enough that it's not inhibiting this video. So our double prime of t, we take the derivative of r prime t, and derivative of 1, well, that would be 0 because 1's a constant. Derivative of t to the negative 1 is negative 1 times t to the negative 2. And then the derivative of ln t plus 1, that's 1 over t, or t to the negative 1. And then 1 is a constant, so that'd just be plus 0. So there we go, that's r prime of t. And that's the second derivative of rt, and then this is the first derivative of rt up here. So then all we got to do now is we got to plug it into here to find the curvature of t. So we'll find the cross product of 1 t to the negative 1 ln of t plus 1, the cross product of 0 negative t to the negative 2 t to the negative 1. I think it'll be easier if, for this right now, we go ahead and plug in the values of t, which we'll have to solve for. So for this, we have to solve for t, to what value of t would give us 1, 0, 0, which is pretty easy because the x is literally just the letter t, and the x in this coordinate is 1, so we know that t equals 1 for all of it. So I think it's easier for doing this cross product if we go ahead and just plug in that value, which is 1, 1 to the negative 1, which is the same as 1 over 1, or just 1, ln of 1, which is equal to 0, plus 1, which is 1. Then we just do the cross product of 0, negative 1 to the negative 2, which is just negative 1 over 1 squared, or negative 1. And then t to the negative 1, which is 1. So then we take the cross product, which right here, I, j, k. So for this one, it's 1, 1, 1. This one right here, it's, well, this is first derivative, the second derivative, so 1, 1, 1, 0, negative 1, 1. Then we'll write this out as I, negative j, and k. So for I, cross product is 1 times 1 is 1, minus negative 1 times 1 is negative 1, so that's plus 1. And then for j, it's 1 times 1, which is 1, minus 0 times 1 is 0. For k, it's 1 times negative 1, that's negative 1, minus 1 times 0. Let me fix that parentheses. minus 0, which is just negative 1. So the vector from this is 2I minus j, and minus 1 times k, that's minus k, which can also be written as 2, negative 1, negative 1, which we still have to find the magnitude of for curvature of t, so don't think that we're even halfway done yet. The other part, we have to find the magnitude of the first derivative of t cubed. So let's go ahead and just write all this out because we already have all the numbers that we need. So that's the magnitude of cross product, which is equal to, I'll write that actually, I'll write that over here. The square root of the cross product, which is 2 squared plus negative 1 squared plus negative 1 squared over the magnitude of the first derivative, which as we know is 1, 1, 1. So that's just 1 squared plus 1 squared plus 1 squared. And then this right here is cubed. So then we just plug all that in. That gives us the square root of 4 plus 1 plus 1. So that's square root of 6. This is just the square root of 3 cubed. And then you can leave it in that form, or you can plug it into your calculator, which is equal to root 2 over 3. And there we have it. That right there, that's our curvature. Hope you enjoyed my explanation. Hope it was simple enough for you to understand, and tune in for next video, which I'll be uploading soon.